And very well. Let's continue. We are talking about assembly methods, and next at least 2 weeks we are going to talk only about the assembly methods. I hope you do remember the definition of assembly method. Let me to help myself with with navigation panel. And as I already said you, I'd like to show you in books exactly where you may read something about assembly methods. Quite clear it comes about our textbooks and manuals. And to remind you also some places from foreign books, at least that bit that we have of foreign books about airplane assembling. I also would like to show you exactly a book and some pages in a book. I hope you do remember that in Mentor you have links. Right now, let's see. Right now, let's see already not attendance, but let's see Mentor. And in Mentor you have topic. After the breaks you have assembly methods. And in these assembly methods you have links to classes, Telegram explanation in Telegram. Actually, you have already seen these classes. I hope you read these classes, but right now I'm not going to use them even. We are going to work with books, as I already said you. And what is assembly method? Each time we'll remind you maybe that assembly method we understand as a set of rules which give recommendations how to reach demanded accuracy of closing link of dimensional chain during assembling. What we understand as that closing link of dimensional chain. Also, I hope you do remember, I even dropped you that picture that we worked with last time. At the bottom, you see examples of the same assembly unit, but on one hand it was assembled on the left. It was assembled by assembly holes, and on the right it was assembled in a jig. Each time we have some size we're interested in, and this size is designated with a red arrow, a red dimension. It means that we are interested in the outer theoretical size of this spar, the height of this spar. How we reach this accuracy of this size, that is the assembly method determined. And each time we see that we have dimensional chain. Each time this dimensional chain consists of 3 links. On the right picture, it's not drawn properly. We know the clearances, dimensions between the jig and the outer cap, but I hope you do remember that it was also chain of 3 links, and we are interested in one of these links, which depends on 3 another links. On the left, it will depending on it's not correct in grammar English. It depends on sizes of parts A1, A2, and A3 immediately. It depends immediately on sizes of parts. On the right, you see dimensional chain, which consists of size of jig and clearances between jig and left cap, clearance between jig and right cap. And each time this dimensional chain is closed with the side of the spar itself. That is to definition of assembly method, what we understand as assembly method at all. Here you also see at the top of slide, you see that assembly method may be classified by bases which they use. And according to this classification, I hope you do remember, base is surface, contour, or point which belong to assembly unit or to assembly component, whether it's part or assembly unit, doesn't matter, which belong to assembly component, and determine position of this assembly component in assembly unit or in some sub-assemblies. Determine this position in item. What we also should remember about bases, that bases may be by the nature of their appearing. So-called project basis, they are not even given in your manual. We have opened laboratory manual, yes, in our great, much helpful. In our manual, no, it's too far. Starting from page 90, we have English text, and here we have classification. You see classification of bases. It's manual about your laboratory works. Exactly, it's page, seems like 91. 91? 91, yes. Classification of bases. Here you not see the base that I have already pronounced it, project base. Project base, it's also the sort of design basis, what assembly base, it's basis of structure, of design itself. And project base, we usually understand like axes, for instance, some main axes, like here you see what main axis of web, main axis of this SPA, which are important for design construction. Theoretical outline is constructed from this project basis. What we understand as design basis? Design bases are real surfaces already. Design or this assembly basis. They are some surfaces, contours, or points. As point, it's maybe a vertex, some corner at assembly component, or more probably it's a hole in assembly component. We understand it as a point. And these bases, they are determining position of assembly component in assembly unit. But in some cases, it's appeared that we have problem, so-called lack of design basis. When design bases not coincide to each other, these assembly bases. And in this case, we are solving the problem of locating by breaking the rules. And that is why, that is the point to talk, breaking the rules of locating, breaking the principles of locating. These principles also describe it for you here in a page 93, principles of locating. You see unity, combination, and constancy. Each time it comes about that different bases by their nature, like assembly basis, project basis, processing basis, they must coincide. And what are these processing bases, also called technological bases? They appear, we distinguish the assembly base and processing bases. They appear because we are not able to use only assembly bases, to use only design bases. That is why we may use either base of, let's see, once again, either base of assembly component or base of assembly tooling, for instance, a jig. And also it's important to remember about bases. Bases may be real, physically exist, you can touch it in real, or bases may be so-called latent. What, for instance, axis of this SPA or axis of any hole, they are latent bases. Their bases, yes, sizes are shown with respect to this basis, like diameter of the hole or radii of the hole. They are shown with respect to the center of this hole, but you can't touch the center of this hole by your finger or by in any another component, because it exists only in your imagination, and also it may be shown in a drawing. In this classification that you see here now by basis, I hope you do remember, we separated all the possible methods onto three groups. One of them, when we have assembly component base and assembly component, and both are real, we may touch the bases, we may align bases somehow. If we are not able to follow the principle of locating with mating only assembly bases, real design basis. In this case, what we do such a trick that we change basis proposed by designer onto some another basis, processing basis or technological basis, but they anyway really exist. That is example of assembling by assembly hole. Instead of outer surfaces we are interested in, we start locating something on holes for fasteners. in the future they are holes for fasteners. And really, designer doesn't interested in designer is not interested, doesn't interested in the position of these rivet holes. Designer interested in the outer surface only. But during assembling, we locating onto these holes in order to provide outer contour with some accuracy. That is idea of locating assembly component to assembly component. Also, in case when we have no real basis, we have latent basis, or at least one of them is latent, we may use so-called marking during locating. It means that we draw this latent base on the surface of real part. How we find position of this latent basis in order to make it visible, it's another story. I hope you do remember. It's possible by measuring and by manual drawing on the surface. It's possible to draw it by template made of wood or made of metal or plastic, whatever, any hard material, stiff enough. Also, it's possible to use photocopy of template, photo template, so-called. Of course, it's extend manufacturing process and it's made it a little bit more expensive, but it's much faster anyway and has less mistakes than using the manual drawing. And the newest, the cutting edge, let it be in this group of methods, it's laser marking. When laser do something like photo print, let it be, the photo of 3D model on the surface of part. And people who see this photo align to these lines. No, as we have seen in movie and in photos, people align a real part to these blinks on the surface of another part. On one hand, it's great because it doesn't take much time for preparing, as only you switch it on, like click the laser, and all the marking simultaneously is appearing. On other hand, of course, it's high-tech technology. It means that at least you need to have all these devices, computer, qualified operators who are able to work with this software and with this equipment. It's not so easy as we might see. Yes, but of course, in manufacturing, it's very simple, convenient, accurate, and fast. What is next? Next, it's a huge group of assembly component to assembly tooling locating. You see here, we have two assembly components with real bases, but these real bases do not coincide, not like in our example on the right. We have real base 1. Here you see blinking the pointer. Real base 2, which belong to different parts, to the left cap, to the right cap. And how to find position of this real base 1 with respect to the real base 2, which we are interested really in. We make element of tooling, here is in the middle, which carry both of these bases, unite them into one structure somehow. And temporarily, in a process of locating, we use this assembly tooling, which is carrier of all the bases we need. This tooling in form, let it be. No, it's not in form. It's not just comes about communication. This tooling really used as physical object. Yes, tooling help us to find position of all assembly components with respect to each other. We are clumping them in this position, either temporarily or even permanent joining with fasteners. And next, we remove assembly tooling. Actually, we remove item from assembly tooling, of course, but in our like toyish formulas, because they are really toyish, they do not exist. I hope you do remember what did I say. We are removing this assembly tooling and we have finished position of assembly component 1 with respect to assembly component 2. What we have in this group of methods, we didn't talk about them, and maybe we will talk about them only next week, maybe even this week, next class. There are so-called contact methods and contactless methods. What does it mean? Here in the picture, you see real jig. Real jig may help you to make real contact with, like real tooling and real contact with real parts. But there exist now tooling of contactless type, but also it's visual. You really may like you may touch, you may align onto this non-contact tooling basis of parts. First of all, it comes about using of lasers, or if necessary, even visualizing of bases with laser beam. It comes about using of coordinate measuring machine and sophisticated equipment. So in this group, together with assembling in a jig, we have so-called jigless assembling, extremely popular in modern manufacturing. But this jigless assembling, of course, has a lot of limitations, because jig is not only carrier of bases. Jig also help us to stiffen the structure. I hope you do remember that elements of airplane structure, they are not stiff. They are losing stability and shapes under own weight. And in order to help to save these sizes and shapes during assembling, we use jig. It's one of functions, important function of jig, not only to carry bases, but also to add stiffness to the structure during process of its assembling. So jigless assembling, it's not it may not be recommended for everything. Jigless assembling is maybe recommended at least for section assembling already. When you have assembly units and you combine these assembly units, you align them, you locate them in during the stage of section assembling. But of course, it's more probably can't be recommended for our structures during the unit assembling level. And also it has another name, old-fashioned names that you may meet in our books even. It's called locating by visual basis. So this jigless assembling, popular name now in Western countries, it's called jigless assembling. Also may be called like jigless, forgive me, locating by visual basis. Locating by visual basis, it's rather old technique. It's in using since middle of 18th years of previous century. So it comes about around 40 years in use already, without any computers, without any complicated devices, even without lasers then. It was already in use. And of course, with appearing of lasers first, next with appearing of computer, with appearing of this CAD and CAM software that you see now is quite common, this 3D modeling, yes. Of course, it became more and more popular, but still it has limitations. Now, let's open a book. And in a book, let's find where assembly methods are described. Page number 70 or 79T or 70, yes. Wait a second. Yep, here. English, English, English. Sorry. Ah, oh, here is 65. Assembly method, page 65. No, I hope you do remember that first lecture here. It's gives the most common, discuss the most common issues like junctions with the name bricks actually. No, not much about junctions, but it discusses it. Next, you have here a bit about diagrams of assembling. I hope you recognize those pictures. And next, you will have here at least short explanation. Some here. Wait a second. Oh, look, about classification. Yeah? And pay your attention. It's possible to divide classify methods on principle of basing of assembly unit, principle of locating, or principle of bases being used. You see here is given another classification, but it's rather similar to what we're talking about, the assembling with locating on fixtures of special stiff jigs, not device. Methods of assembling of by visual optical basis. Here is assembling by marking, and assembling by base part. They divided in all these methods into another groups, but it doesn't change the matter. Once again, what you see now, principles of locating, it's the same that we are talking, what assembly methods, assembly component with real basis, assembly component with latent basis, assembly component located to assembly tooling. Also, in our laboratory manual, you have classification. Do pay attention of assembly method. Very similar to what we are talking about. It's about basis. Do pay attention. Methods classified by locating principle belongs to one of assembly components, yes, and it comes about, if we compare to our slide, it comes about to this group and to that group, yes, and assembling by basis belong to one of no, assembly component and technological tooling, the last group. Here we see three groups: assembling in a jig, assembling in contactless coordinate system, and assembling with using of equipment. What we understand as assembling in contactless coordinate system? It's what did I say already about optical system and lasers before appearing of computers. What we understand as assembling with using of equipment? Assembling with using of coordinate measuring machines. I hope you do remember that they may be of very different types, and at least two of them, like laser tracker and like so-called measuring arm, on-site measuring arm, they may be used during assembling of aircraft airspace structures, and with limitations, of course, as I'm already said you, that some things they are not recommended for such assembling because they are not stiff enough and better to assemble them in a jig. In a jig, in turn, I didn't say it yet, but I hope you already read it, and must be I have mentioned it in our previous class. In a jig, you have opportunity, no, as we are talking about bases, aligned in a jig, and base is surface, contour, or point. In a jig, you may do locators or fixtures, as it's mentioned somewhere in another book. You may do locators of surface type, of linear type, like the line repeated, and you may do locators of points in a view of hole or in a view of pin. What about these surfaces? Actually, surface may be represented as a grid of intersecting lines. No, I hope you may imagine this without visualization right now for you, that you may have some locators parallel to each other and locators which transversal, which are normal to another group of locators. As a result, you have grid of locators which repeat the surface. Pictures, we may find such pictures, but right now don't need it. And usually, if we need to locate the whole surface, we use either some parallel locators or some locators which are perpendicular to each other, but we do not try to repeat the whole surface in a jig. If even you need this surface, normally this surface is represented with some linear locators, with some fixing arms. So we have techniques mostly which work with contours in a jig, not with the whole surface. Exclusion is only a work with composite materials, when you need not only locate something, but you also need to clump layers to some surface, the whole surface, in order all some, you understand must be that composite materials, it's some layers that you need to clump together. And to clump together them, you are clumping them to another surface, to the tooling surface. And in this case, of course, it's necessary to repeat all the form in a jig. It's exclusion in this case. But normally, if it comes about metal, about wooden structures and polymer structures, we are not working with surface locator, we are working with contour locators. These contour locators are represented next in three different techniques. One is called locating to the outer surface of skin. Let's see here in the book. Now, it's not what we need right now, and it's in another language. Here is. It's called here variety of assembly methods in a jig. Don't pay attention to the word device, and I demand you to use word jig always. One of them to external surface, or it's called by skin. Another of them is to the inner surface of skin. Let me to show you. Skin, not internal surface of skin, or it's also may be called by mock-ups, by mock-up element. Next, third one is with locating to the surface of framework, as you might see, to the surface of airframe, or it's maybe called by airframe or just by frame. Well, by contour, once again, we have three methods. By skin or external surface, outer surface of skin. By inner surface of skin, where it's written, not here. Yeah? Maybe it's the, but at the bottom here, inner surface of skin. And third one is with locating to the surface of inner structural elements, airframe. Frame, rims, ribs, stringers, and so on. It was about locating to surface. What about locating to holes? When it comes about locating to the point, I hope you do remember surface, contour, and point. Point, as I said, usually we understand as a hole. Locating by holes. Holes in their turn may belong to component, assembly components only, or holes may belong to one hole is realized in assembly component, another in assembly jig. And one big groups of such assembling we have already started even. We didn't talk much about them as a method of assembling, but you know this. Look at this. Assembly method with locating onto holes of joint balls, GBH holes. And I hope you recognize at least some pictures. Oh, great. That one. And I hope you do recognize the pictures of these comb-like parts, comb-like fittings, which next we're talking about them in the structure, in the topic of junctions, and we're discussing mostly that we have holes which responsible for locating of aggregates with respect to each other, like wing, center, wing. And with relation to that question, we have also discussed that these holes positions, their axes are extremely important, and these holes must be here you see the picture of flange junction, here you see picture of fork type junction. These holes must be aligned since beginning. They must be coordinated to each other and to the theoretical outlines, and that is why they are located. Parts with such holes, they are located only in jigs. And it means that in jig, each time you have special locator, which is responsible for positioning the part with this GPH hole. And I hope you do remember that it comes about holes not just joined by bolts. It comes about holes which are empty. Empty during some stages of assembling. Empty until they do not meet each other in different aggregates, maybe even at final assembling already. not even section assembling, but final assembling. Так. And there is another group of holes. That is so-called design hole. Design hole, which is appeared because of need of design. And another group of holes, it was before even, it was explained even before explanation about surface locating. Here is, let's do it a bit less. No. Да. You see here something right now. CFH and locating by assembly holes. Now, assembly holes, as I already said, and I hope you do remember, assembly component to assembly component, and it means that it's in the first group. Assembly component to assembly component. No need in a jig. What about the CFH hole? What we understand as CFH hole? CFH hole, coordinate fixing hole, or BH hole, base hole. Practically it's the same. What is the difference? We'll explain in a minute. CFH hole or BH hole, from viewpoint of designer, it's not necessary hole. It has no function in aircraft during aircraft functioning, during aircraft operating. It's not necessary. It's extra hole. And such holes, they are appearing in structure by demands of manufacturing engineers, by demands of technologists. Designer proposed such a hole. They do this hole immediately in structure. They are appearing in structure at the stage of designing exactly. But these holes are not necessary in structure design. And these holes, they are one in a assembly component, another in assembly jig. Now, these pictures, they are a bit complex because they combine both demonstration of assembling by CFH holes and by so-called BFH holes. First, I didn't say you yet, what is the difference between CFH and BH? BH usually is understood as hole on the axis. For instance, look in these pictures. If we have hole immediately on theoretical axis, it may have name base hole. If you have such a hole, which is not necessary from design viewpoint, but it's necessary for locating or some other purposes during manufacturing, usually they are called coordinate fixing holes. And these coordinate fixing holes normally are made in a grid 50 to 50 millimeters with respect to the main design basis. What is BFH hole? What is the difference between BH and BFH? BH, base hole, it's, as I already said you, hole in assembly component and tooling. BH hole, we understand. BFH, it's practically another name of AH hole. AH, assembly hole, it hole in part and part. BFH is understood. Do pay attention. You see also, no jig, no anything else. It's hole in assembly component and assembly component, but assembly component in this case is already assembly unit. It's already assembled, pre-assembled from some parts. So here we have assembly component and assembly component. And here you have assembly component and assembly component. And difference only in their complexity. No principal difference. Names are different. Assembly hole, part plus part. Base fixing hole, assembly unit plus assembly unit, but principle is the same. Assembly component is located to assembly component. When it comes about base hole and CFH holes, difference is significant because it comes about locating of assembly component, whether it's part or assembly unit. Look, here you have part picture, here you have assembly, no, here is the part picture also, which is located, seems like it's one part, yes? And here you have assembly unit, the whole spar, which is located by CFH holes into jig. So here, once again, coordinate fixing hole, whether it's component as a part or as assembly unit, it's whole in tooling in a jig and whole in assembly component. If you see that you have respective holes, let's say, which correspond to the holes in your assembly component in another assembly component, their names either assembly hole or base fixing hole. If you see hole in a jig and in assembly component, it's coordinate fixing hole or base hole. It's just stable terminology in our countries, and it's not quite the same in Western countries. They may just call them assembly holes altogether, like everything, yeah? Like holes for assembling. Or they also may call it locating holes. So general name, common name for all such holes, except of GBH, of course. GBH is called GBH in Western countries either. Locating fixing hole or adjusting fixing hole. And here in a picture right now in diagram, you see another classification once again. And to pay your attention, this classification is based on some third principle. Да? It doesn't come about what these bases belong to strictly, because no, you see that we were talking. Suppose it to be big, two big groups, and third, the second group is like, suppose it's separate group, no? And this one and that one, they are practically the same. They have different names, but practically it's the same. And here in this, if they are talking about classification of assembly by holes, no? It's supposed to be mentioned also one more type of holes, GBH holes. So be attentive to all these classifications. I said it since beginning that all classifications, they are directed onto helping you to understand something, but they don't give, they all have lacks, they all have white spots, let's say, some places where they do some mistakes or they have some lack of explanation. Once again, it was classification of assembly methods, how to get accuracy by basis which these assembly methods used during assembling. And now we're coming back to another classification. And this another classification, my dear people, it was classification based on degree of interchangeability. Wait a second. Oh, technologies of first lecture, first ever lecture. Why? No idea. Why? No, let it be. Do pay attention here, as we already see it. Do pay attention to the list of questions. For instance, you have something like combined questions. As what? Assembling by surfaces of assembly component and assembling by assembly holes. Assembling by marking, by CFH, by GBH, by visual basis. Variety of assembly methods in a jig. It means that you're supposed to explain practically everything, no? But shortly about jig methods, both of surface method and of hole method. At least mention all them, at least 5. No? Next, assembling by holes in airplane manufacturing. And in this place, you're supposed to explain that we have so-called GBH holes, we have CFH holes, we have BH holes, assembly holes, basis fixing holes, and so on. No, I hope you understand. It's so-called combinative questions. And you have questions which directed only to one of such methods, like what you see, by scheme. Now, let's come back here, because I'd like you to show, no, to the book also we'll come back in some seconds. Wait a second. Так, да. Sorry. To remind you, all those classifications we just discussed, no? And additionally in eject, here you see we were talking about. And next, what in this file that you have, assembling fundamentals, you have this file in a group. To open the whole file, if any problem, you see how to find it. No, it's just demonstration, it's just presentation, it's practical without text. And here you see referring to the book once again, principle of locating, principle of basis being used, and principles of degree of interchangeability providing. What we are going to talk about right now is this degree of interchangeability. Where it's written in the book, I said, I'm trying today to refer exactly on the book. Pay attention that it just mentioned it once. Forgive me, let's find it again. Once it's mentioned, what here, depending on degree of interchangeability. And practically there is no explanation. Anything. No explaining. Depending on degree of interchangeability, and that's it. I have explained it a bit in my Telegram explanation, and left you what I have mastered to find in Western internet resources. Not much, to be frank. And I'm going to show you where to read more about this matter in a book, exactly in this book. And next, whatever I explain, do forgive me. No place to read. You need to make notes in order to answer these matters in exam. And you may rely only onto your notes and my Telegram explanation and on that little, let's say, that we have in a book. Sorry, it's after, or you see picture now about visual basis. It's after all the techniques of assembling been explained, and here it's given some comparison of different assembly methods. In this comparison, you may find this method mentioned. Assembly by CFH, assembly by BH, assembly in a jig with locating to outer surface, and so on. It's yet about principle of locating, and here a little bit as a whole, introduction to the level of interchangeability, you see, these words, is a little bit explained about what we're going to talk about. Really a little bit. And next it's given table of comparison. Pay attention. Here is assembling by methods of incomplete interchangeability, assembling by method of group interchangeability. You see. And that's it. Now let's talk. Let's find, as I said, our Telegram explanation. And let's talk about not classification, but let's talk about characteristic of assembly method depending on their degree of interchangeability. Not the value of accuracy what they provide, because when we're talking about locating with different bases, we also characterize their accuracy exactly. What is the value of error this method are characterized with these methods. When we're talking about their methods classification on degree of interchangeability, we are talking about the, I hope you understand, about the repeatability of assembly methods, how they provide similarity of assembly units. Let it be with some fixed range of errors, with some accuracy. But how to provide stability of this accuracy? It means that interchangeability of items you're going to assembling. Do pay attention. Here you see names of methods. If I were you, I would copy them immediately, and additionally I will pronounce it maybe with a bit changed names. assembly methods also may be classified onto 4 different groups depending on degree of interchangeability which they provide. Assembly method with full interchangeability, or so-called complete interchangeability. Do pay attention that third one here, and I'm going to use it as a third one, which has non-similar name, this selective assembling, not selected, but selective assembling in English, method of so-called common interchangeability or selective assembling, is practically the same as assembly method of full interchangeability, but with little trick. Practically, it comes about the same story. Next one, assembly method with limited or non-complete interchangeability. Third one, here it's written as second. Assembly method with non-complete or limited interchangeability. And fourth one is assembly method with adjusting, not fitting, but adjusting. We may call it by assembly method with using of fitting, but really it's better to call it assembly method with adjusting. And once again, it comes about how to provide repeatability during assembling. What does it mean something interchangeable? Some assembly unit is interchangeable if it may be used instead of similar assembly unit or the same assembly unit with preserving the quality and without any additional adjusting. Interchangeability is a property of structure or any object to be used instead another object with preserving the quality but without any additional work. And I hope you understand that it comes about geometrical interchangeability in our case. It means by sizes, yes, by sizes and shapes. It comes about mechanical interchangeability and it comes about physical interchangeability. What does it mean, mechanical interchangeability? It comes about mechanical properties, strength, deformability, ductility, fatigue life, so on. When it comes about physical properties, above the all, we are talking about the weight, mass of this structure. And above the all, we are interested once again in geometrical interchangeability. Mechanical and this physical interchangeability, weight interchangeability, it's already so-called by default. It's supposed to be without any mentioning. It should be made of the same materials, it should be made of the same state of materials, so on. Да? Now we are interested in how to provide geometrical interchangeability during assembly. No, can't give you any illustration besides of what we have in wait a second. Sorry, not yet. What we have in our another books. Now, да. Ну вот, let it be. So, technique of complete interchangeability. You see, I have opened a book, similar book, but this similar book is not in English. I will try to do something in this matter for you, but can't promise, especially considering our situation with electrical energy. First, technique of full interchangeability providing. Так, now computer is hanging. Great. Да. No, very well. Whatever I do to computer right now, it doesn't work. So just listen and write. What we understand as assembly method with full interchangeability providing. It's assembly method which is based on using system of fit and tolerances. What is system of fit and tolerances? I hope you do remember. It's a system which normalizes tolerances, normalize errors of paths. Once again, method of full interchangeability providing is based on using of international system of fit and tolerances. There are a lot of, not a lot, but two different names of systems. Computer, are you working or not? A bit. And maybe it's no, I haven't opened this article in Wikipedia, but even in my Telegram channel, you may find such explanations. No, approximately. Oh, what? Pay attention. Yeah. For instance, here you have a file, by the word for you, extremely useful file right now for your bachelor works. If you have any problem with understanding how to make sizes, how to show bases, and so on. And here I have a bit more before your very first laboratory work even. Where it started, you see, no? Those things already. Also about dimensioning. And here in the beginning, here, somewhere here, you have, you have explanation that there are at least two approaches, similar in general, a bit different, but similar, which exist in Western countries. One is in USA, Canada, and related countries, and another in countries of Euro Union, in countries which are working with ISO standards. And they have different system of standards, but they have, no, you see, no? This standard name is ANSI, and another standard name, what ANSI or ASME, it's American Society of Mechanical Engineers, and American National Standard Institute. And on other hand, they have ISO standards. Names of this system, they are similar: geometrical tolerances and dimensioning, tolerancing and dimensioning, and another. No, right now, do not recollect these short names, but they are similar. What here is another system you see based on metric system of units of measuring, ISO standards, and they are extremely similar. Besides of some, in basic terminology there is difference, and in Western countries they understand, they include into this system a little bit more characteristics of surface finish, if I'm not mistaken. And surface finish, it's three characteristics at least: surface roughness, lay, and waveness. Well, yes, here you see, in order to remind you what we understand as system of fit and tolerances. We have so-called international tolerance grade, and this international tolerance grade, it's normalize the value. I will drop it. It's not beginning, but at least somehow it will help you to find if you need it. It's normalize the level, the area of possible variance of sizes, so-called tolerance. And what does it mean assembling with full interchangeability? It means that you do write down this case, that it means that you do accurate paths, and final accuracy of assembling belongs depends on accuracy of paths. Accuracy of assembling is a result of accuracy of paths. So using the less tolerances fields here, the more accurate tolerances, quite clear you will have more accurate assembling, more accurate assembly units. What is advantage in this case? Advantage is that during assembling, on one hand, you don't need any adjusting and you don't need any complex work. You're just attaching parts to each other. No, it's in terms of which basis to use. Now, you're just mating the parts, and due to coincidence of surfaces of parts, you have already some accuracy of assembly unit. So during assembling, everything is fast, simple, and seems like cheap because you don't need additional assembly tooling. But how you may increase accuracy of assembling in such a case? Only by increasing accuracy of parts. And I hope you do remember that if we're talking about increasing, changing to the better, let it be, to the more accurate, one level of this international tolerance grade, no, for instance, from 16 to 15, it comes about increasing 10 times the cost expenses for manufacturing of such a part. And what does it mean to increase accuracy of assembling, for instance, if it comes about this technique of interchangeability providing? It means that if you have 5 parts and you'd like in this assembly unit and you'd like to make something more accurate, more probably this more accurate means 50 times more expensive parts for manufacturing. Assembling only, for instance, some dozens of millimeters more accurate, but expenses for parts manufacturing increase sometimes and some dozens of times maybe. So on one hand, in terms of assembling, this technique is great at all because during assembling you are spending less time and less money, and you don't need much preparation for assembly manufacturing because you have no need in jigs, if only some primitive jigs. And when it comes about their manufacturing as a whole, including with manufacturing of parts, of course it's inappropriate because you need to increase accuracy of parts, and any changing in accuracy of parts significantly increase expenses for this parts manufacturing. And other problem, no, one more problem, that do pay attention again to these pictures. Где это было? Да? Вот. To this one, for instance. What it comes about? Is it somehow similar to aircraft part at all or not? Certainly not much of aerospace parts looks like this. Massive, stiff, and so on. Yes, we have such parts. So such technique may be used somewhere in elements of our structure. But mostly it comes about the systems like pneumatic system, hydraulic system, maybe somewhere in passenger chair we may use technique of such assembling, providing of interchangeability. But certainly the most of our parts, they are too much delicate. Delicate. The most of our structures, they are right now, no, even those who, what do we see here? Parts are thin, parts are non-stiff, and using of assembly technique with relying on to accuracy of these parts themselves, certainly it's not possible because parts may change shape and sizes under their own weight, and moreover when you apply additional loads like this. No? This man is drilling something, in another place we see that someone riveting something, even elementary things like clamping the parts, it's already distort the shape and sizes of these parts. So technique of interchangeability with full method of full interchangeability, it doesn't work in our case, just because we have problem with part stiffness. And once again, great technique in assembling because it's able to provide full interchangeability, and it's fast in assembling, and it does not demand any additional time and expenses for preparing of assembling exactly, as we have no need in jigs, for instance, especially in special jigs. But this technique in general in manufacturing is extremely expensive, and this technique is applicable to the mechanical to the assembly components of so-called mechanical engineering, but not to aerospace engineering, or at least to the most of these aerospace engineering components. Next technique, as I said in our slides, it had a similar name, the like full interchangeability and non-full or incomplete interchangeability, but we skip it right now because if even it has similar name, it's not really similar in manufacturing. Next, it was selective assembling. Computer hang again. Thank you, computer. What happened? What is wrong with you today? Maybe this file is hanging, not computer. Maybe. No, sorry. Next one is selective assembling. And. Let's try to. Let's try to come back. I said no. Files you have here. I trust. Or not. Or not. You have or not. You have here selective assembling file that I said you to read. Oh, here is. Да? It's a movie, and here is you have this group interchangeability method for selective assembling. Let's do it now. And I propose you to watch this. People, if you, not if, but when you open this file, you might see here complex mathematics. I'm not insist you even to understand this complex mathematics. I don't need it currently because they, on one hand, they describe the idea, the concept of this method. On the other hand, they give also recommendations, practical recommendations how to use it in manufacturing. So where you see something more complicated for you than you wait, I permit you not even to read this, but concept of method is described here. Let's I'm not satisfied with behavior of computer. Again, да. Так, завершить, да. Let's try to open it once again, and maybe in this case will be more successful. To see the picture. We'd like to see the picture. Oh, look at this. What this picture is about. What do you see in this picture? Now, once again, do pay attention to what has disappeared again, да? Do pay attention. Do pay attention here. What do we see? We see this pink color. What here is? It's field of tolerance of part. It means that parts may be at least with this size, at maximum, да, with this size. And quite the same it comes about another part, which is assembled with the shaft, part with the hole. We have tolerance zone, and you see that hole may be the greatest, the biggest, and hole may be the least. Your task is to provide some accuracy, some clearance between these two parts. Pay attention now, and let's do it even. 1 live. Look, what may be combination possible ultimate combinations of sizes. For instance, if whole has the greatest size, we have greatest whole, and shaft has the minimum size. Here is. So what is a clearance possible if we have these fields of tolerances? Clearance is this gap between paths is like this. And once again, what is the possible minimum case when we have the minimum whole? Here is now, sorry, not much successful. Minimum whole size, and we have maximum size of the shaft. And what is the possible clearance? Like that. And what do we see, my dear gentlemen? Now I hope you see clearly, in front of you in the screen. The clearance may be starting from this to that. What if you'd like to make this clearance more narrow? If you, it comes about not one couple of paths. I hope you do remember. It comes about hundreds of parts you are manufacturing, or at least about batch of parts. No, 20, 50. But normally in manufacturing, it comes about hundreds and thousands of parts. And no, I have shown you example with clearance, but maybe even worse example with overlapping, or so-called transition fits. When you'd like to have little interference, but not much. But instead of this guaranteed interference, you have either clearance or tight, significant tight, and in this case, you are not able to provide a functionality of parts. So do remember, for instance, the pencil, usually I use in examples, pencil and cap for pencil. Everyone is able to imagine it. Moreover, you have it in front of you, I trust. And what if the cap is much greater in size than pencil? In this case, this cap became pointless. As only you put it onto pencil, it's dropped back. It's not hold on the pencil. What if the cap is much less than necessary? When you put it on the pencil, you are not able to remove it back. So in this case, you'd like to have some stable and little clearance between shaft, pencil, and between cap, the spot with hole. How you may reduce this clearance, how you may do more accurate this clearance for thousands of parts? No, quite clear. In the accepted concept of this full interchangeability, you may do more accurate parts. But more accurate parts means more expensive parts. I hope it's clear. What the picture that we see right now, not here, here. What this picture demonstrates us. Let me show you again in Telegram. It demonstrates the fields of tolerances, no, in case of their overlapping. In our example that we see immediately behind this picture, you see a case with clearance, and here you see case with overlapping. The tolerance field of one part, no, let it be that is like in our example, it was on the left we have hole, on the right we have shaft, like it was here and there. These pinkish fields of tolerances, here you see one field of tolerance and second field of tolerance, either here or there. And we'd like to guarantee quite the same value of clearance between paths of all the possible variants instead of this no, wide range of variants. Big clearance, little clearance, interference, so on. Special trick being used. Look at this. No, I hope you understand that. Let it be that is the pencil at the top, and here is the cap. What if we have pencil out of this group? Pencil has size greater than cap. You can't insert pencil into cap. What you have if, in contrary, here is the possible minimum size of pencil and possible maximum hole size. Да? What we have? No, minimum tolerance, let's say. Too big clearance and cap is not hanged, not placeable firmly onto this pencil, because pencil is much less than hole in a cap. What trick is used here? Do pay attention. All the paths preliminary divided onto 3 groups. The value of tolerance, I hope you are writing, that is why I'm talking so slowly. The field of tolerance, the value of tolerance, is divided onto some subgroups, some subranges in both of paths. And during assembling, only paths from respective groups are assembled in order to guarantee the recommended clearance or interference, in order to guarantee recommended fit. Do pay attention. Each time, instead of whether interference, like it was here, in this case, it's possible. Let's think what we may have. Either we have interference when paths are really interfering, да? Here in this region, or we have significant clearance between paths if we have the full tolerances. What if we have these paths from group number 1, group number 2, or so on? Look at this now. In this case, whatever you do, you have clearance, but clearance may be of different size. Clearance may be like this, clearance may be like that. Yeah? One variant of clearance and another variant of clearance. What if we'd like to work with third group of paths? Look at this. Once again, third group of paths. The same. Look, you have clearance here, да, between the possible minimum possible clearance here is, and we have clearance again, the gap between possible maximum sizes. So whatever, whichever path you take, that one, да, that one, you may find companion for this path in order to provide this narrow field. With respect to this, you see, да, it's narrow field of fits, whether here or there, or for second group, and without any changing in accuracy of paths. So what is the idea of selective assembling? Let's send it. Да? What is idea of selective assembling? That you do not change accuracy of paths, you do not narrowing their field of tolerance, value of tolerance for these paths, but you increase accuracy of assembling anyway. How we increase accuracy of assembling? Due to preliminary selecting of paths onto some subgroups according to subgroups of tolerances. How to subdivide them, this tolerance preliminary it's another story. It's include mathematical assessment of tolerances, of the combinations, and so on. You may read it in a file. How they do it in manufacturing while preparing of manufacturing, it's another story. What it looks like in real manufacturing. You or your employee have the whole box of parts. You give to your employee some measuring device. Normally, it's not even device for measuring, it's device for comparing, like gauges. You have studied this in interchangeability. C-type gauge, no? Or some another type of gauge. And this employee just taking parts one by one from the box and assessing whether it's in the range this gauge provide or not. And due to this, you may, no, not you, but your employee, may select parts into some subgroups. And another assembly component, which supposed to be assembled with these parts. Also, you have a box with assembly components and someone, before assembling gets started, someone selecting these assembly components, again with using of universal measuring devices, which don't even demand employee to think. They just work as you attach something and compare whether it's coincide or not. And after you have preliminary selected all the assembly components into equal amount of subgroups, you are able to provide more accuracy of assembling with the same accuracy of parts. In terms of money of manufacturing in general, it's not significantly increase the expenses comparatively to what it was in the case of using of fit and tolerances techniques. When it comes about of increasing accuracy with full interchangeability approach, it was due to increasing accuracy of parts. And this increasing accuracy of parts significantly increase expenses for manufacturing of parts. When it comes about their assembling with selected interchangeability, you do not increase accuracy of parts, but you are able to increase accuracy of assembling. Of course, it's extend period of assembling. Before you start assembling, you need to select parts onto some subgroups. Of course, it's extend a bit the lead time, the preparation time of assembling, because also you need to make some calculations to assess which groups you need, so on. And of course, it's a bit increased expenses for tooling, because in this case, instead of couple of gauges for this side and for that side, you already need, if you have 3 groups, you need 2 gauges for each side. No? Instead of couple of gauges for shaft and couple of gauges for the hole, you need, in this case, you need 6 gauges for both of these parts. And yes, it's increased expenses for tooling and time for tooling preparing, but so insignificantly that it's not even to talk about actually, because this universal measuring device, you don't need to design them, you just need, literally you need to buy them, and that's it. And they are cheap, comparatively cheap, comparatively to assembly jigs and other technological tricks. Now, once again, let's stop on this, maybe in our explanations. And once again, what we were talking about, besides of like coming back to the general characteristics and so on, we start talking about the assembly method characteristics by the principle of their interchangeability degree providing, how they provide this interchangeability, and whether it's full degree interchangeability or it's not complete interchangeability. In a book that you have seen and that you usually use, forgive me, I don't like to jump again to that previous place. You have seen 4 names in the beginning of explanation, somewhere page 70 maybe. Okay, let's jump. page number 103, and there it was page around 70. Somewhere here. Oh, да, 71, да? In a book, these techniques are listed on the page 71, and they are a bit described in a page 103 after the whole explanation as to, да, вот, somewhere here it was. Yeah, yeah. After all explanation about assembly methods and after their comparison. In terms of their comparison, here it's a bit explained. I hope you see. In telegram explanation, you also have little bit, or nightmare. You also have here in telegram explanation, literally a bit, now with classification by interchangeability degree, you see. And in addition, you have a little bit more that I found about the selective interchangeability or this group assembling, no? Group interchangeability. You have movie and you have article to read. Next time, we'd like to talk about the non-complete interchangeability providing and providing of interchangeability due adjusting. Once again, we are not talking about basis in this case. We are talking only about how interchangeability is provided, repeatability of objects is provided, and what it cost us in terms of quality, money, and time. Money and time both for preparation and for manufacturing. I hope you understand already that full interchangeability, it means that you use normalizing of tolerances of parts, and in order to increase accuracy of assembling, you increase accuracy of parts. And of course, it's just soaring the price, the expenses for manufacturing in general. In case of selective interchangeability, you also rely upon the normalizing accuracy of parts. But in this case, in order to increase accuracy of assembling, you don't need to increase accuracy of parts. You just need to make some additional work before assembling. Immediately before assembling, you are selecting parts onto some subgroups with narrowed value of tolerances. Parts are the same, but you select them onto subgroups, and next you combine parts in assembly unit only from respective subgroups, as it was shown in this symbolic picture, no? Where we have value of tolerance of one assembly component, value of tolerance of another assembly component, divided onto some subgroups, and next you combine parts with respective subgroups. Let's stop on this, our record at least.